Welcome to the module, Making the Most of Meaningful Math Tasks. Today we are going to look at the components of Cumberland County's meaningful math tasks and some best practices for using these tasks. Today's expected outcomes are to understand the concept of upside-down teaching, which directly relates to the meaningful math tasks, identify the purpose of the meaningful math tasks, to engage in a meaningful math task, and then we're going to look at some tips for differentiating and for planning instruction around the meaningful math tasks, and then take a look at some of the new tasks on the CNI Google site. Before we get into examining the meaningful math tasks, I wanted to start by talking about the process for using the tasks in the classroom. It is strongly recommended that every day when we start a lesson, we start by giving the students something to grapple with, for example, a task to grapple with. Then the students should have opportunities to share their solution strategies and their thinking. And then finally, the teacher then provides their direct instruction and guided practice. And that direct instruction could be on strategies or tools or any skills directly related to that task that the student started with. Kathy Seeley, a leading math educator in our nation, refers to this process as upside-down teaching. She has actually written an article on upside-down teaching, or a chapter of upside-down teaching, in her book. And this process, which many math educators and researchers agree, is a lot different than the traditional way of teaching. That traditional way of I do, you do, we do is definitely not effective in math. This process just means that we start a lesson by I, the teacher, modeling something, and then we, the teacher, and the students practice it together, and then there's this gradual release where the students do it on their own. But in math, that's not effective because we don't want the students to gradually be released into the wild to just blindly replicate what the teacher has told them to do. No, we want students to think for themselves, to pull their prior knowledge into it, to think about what they already know that will help them in new situations. And that's why we want to start off with that grappling. The upside down teaching that Kathy Seeley refers to follows more of a you do, we do, I do approach. Or that means you, the student, try it out. We're going to talk about it in a math talk, and then I, the teacher, will then model some strategies for you and make sure that you reach the lesson's goal. For more information on this process of upside-down teaching, check out the article that's posted here by clicking on the book or by going to the website at the bottom of this page. As we complete the rest of this presentation, be sure to keep thinking back about that upside-down teaching and be thinking about how that upside-down teaching is evident in everything that we're doing with the meaningful math tasks. The next thing I wanted to touch on briefly are just the components of the meaningful math tasks, so what's available on the CNI Google site. You will notice that there's two types of files on the CNI Google site. The first one is the student tasks, and that file is a PowerPoint, which means that you can manipulate the tasks there. This allows you to personalize the tasks for your classroom by changing the students' names or changing the situation or even changing the numbers if you need to, depending on the students that you're working with, if you're working in a small group versus whole group. The other document, the other file, is a teacher's guide. The teacher's guide has a lot of really important components that I wanted to just review or touch on really fast. On the top left of this document, you will notice that the pacing of when we teach the tasks is here. That pacing directly matches the unit analysis. Then we identify the content standards and the practice standards that are addressed in this task. In the bottom box, you will see suggested materials. We've made a couple modifications to this right here. Now we've also suggested some virtual manipulatives that can be used on different tasks. If we've made a suggestion about virtual manipulatives, if you're actually in the electronic file, you can click on that virtual manipulative and it will take you to that website. Another thing that you might see in the suggested materials are any Blackline Masters templates, any work mats that might be printed, and if those are referenced there, those will be in the following pages of the Meaningful Math Task Teacher's Guide, so you could just print them out right from there. The next part is vocabulary. That's vocabulary that the students have to be able to use and that the teacher should be modeling. And then you will notice the questions for Math Talk. These are questions that the teacher should be asking as the students are sharing out their solutions after they grapple with the task. The next part is the teaching points. This is probably the most important part. A teacher will probably not use every teaching point listed. However, instead, what the teacher will do is, as the students are grappling with the task, as the teacher is watching them grapple, as the teacher is listening to that math talk, the teacher is going to pick one or two teaching points to address in the direct instruction part of her lesson. In fact, the teacher might even not know exactly which teaching points she's going to use until she actually hears the students grapple and do that math talk. The last part of this document is the connection section. This section makes connections to either previously learned standards from the last grade level or from prior grade levels, or previously learned standards from earlier that school year. This makes it really nice so that you can know what the students already learned and you can easily make connections and draw on their prior knowledge. At this point, I normally ask teachers to engage in a task with me when I'm doing this session face-to-face, and I pretend to be the teacher, and I ask them to pretend to be the student. For today's purposes, I'm just going to walk through the steps for implementation of a task. As I walk through this task here, I want you to think about how this really relates to the upside-down teaching that we were talking about. So the task we're going to look at is about John. This is a first grade task from Unit 2. Before we go into the task, though, I wanted to point something out really fast. Research is now telling us that when students see a word problem, they immediately jump to that question and try to answer that question by just doing something with whatever numbers are in the task. Now, I don't think we really needed research to tell us that, since I think any classroom teacher probably could have told us the same thing. But what that same piece of research found, which I do think is really interesting, is that if we cover up the question and just give the students the information, just give the students the sentences, the statements, they will start to treat this more like a reading passage. And then those students are more likely to use close reading strategies like visualizing the situation, thinking about the main idea, the characters, and so on. So what I did here was I started by covering up the question. What I would do at this point is I would just read, John has 3 children, the sum of their ages is 20 years. I would have the students think silently and then turn and talk to a partner about what they notice about this problem. And then what do they wonder? And that could be very open-ended. They could wonder pretty much anything with this. Then I would have the students pretend that they are the teacher and have them create a question for this problem. Then the next point is I'm going to reveal the question and have the students compare what questions they came up with to the question that's here on the task. At this point, I would also remind students that covering up the question and just thinking about the situation is a great problem-solving strategy that can be used today and every day, including the day of the EOG. So now that students know the question, I would allow some think time for them to grapple with the problem. And I would adjust the think time based on the task. A lot of teachers say to me, well, I don't know what to do. They're just sitting there. They've already grappled, and some students are still working, some aren't. You really have to watch. And sometimes if the students don't have a lot of prior knowledge about something, the grappling might just be a few minutes. Especially if it's like a totally new concept, like you're just introducing multiplication for the first time. If the students are productively grappling, let that grappling go on for a while. There may even be times where you might need to pull the whole class back together, ask a couple clarifying questions, or redirect the students or provide a suggestion for getting started, and then let them go back to grappling for a few more minutes. As the students are grappling, you really need to watch the class, take some notes even, on 2 to 3 students to share their solution strategies with the class. Make sure to tell those students ahead of time so they can plan out what they're going to say, or even sometimes have those students rehearse what they're going to say with a partner. Then refer back to the teacher's guide for the questions that you're going to ask during the math talk as they share. And then lastly, like we said before, after the students are done sharing, select 1 or 2 teaching points for the teacher's guide, and that will serve as your direct instruction and your guided practice. So hopefully you are starting to see the difference between that traditional style of I do, we do, you do type of teaching and this upside down teaching of you try it first, we will talk about it together, and then I'm going to give you some instruction to make sure that you get the goal of this lesson. Remember, the grappling, again, may be short or long depending on that situation. In a few slides, we're also going to discuss what to do if some students finish grappling while others are just getting started. There's also a page in the front matter of the teacher's guide that outlines the steps that I just discussed about how to implement one of the tasks. And you can see that page right here. So we've been talking a lot about this term math talk, as in after we finish grappling, the teacher conducts a math talk to hear the student solutions. Math talks were introduced to Cumberland County teachers a few years ago. This process encourages students to listen to each other as others are sharing out strategies. What I wanted to do really quick was just go through the steps if this is a process that you have not heard before. First, what the teacher would do is after grappling, after the students grapple with that problem, the teacher is going to pick some students to share out their strategies. So the teacher would say, so-and-so, can you tell us about how you solve this problem? This is when these math talk moves or these math talk steps come into play. So the student's going to share out their strategy, and then the teacher is going to revoice. So the teacher is going to make sure that she restates what the student says, sometimes a little bit more concisely, sometimes a little bit more specific so the other students can hear what she is saying and understand. So for example, the teacher might say, so what I hear you saying is you added by blah, blah, blah. So paraphrasing what the students say. Then the teacher would say, is that indeed what you meant to say? So after that happens, then the teacher is going to get other students to repeat what happened. So revoice and repeat are really the same thing. It's just that the teacher is going to revoice, and then the students are going to repeat what that student said. So the teacher might say to Joey, can you repeat what Susie just said using your own words? And then we would go back to Susie. Susie, is that what you meant to say? The next part is the students talk about, do they agree or disagree with what Susie said? So the teacher says, give me a thumbs up if you agree, tell me why you agree, or tell me why you might disagree. And the students would have to critique and reason with what Susie said. And then after that, the teacher would give the students an opportunity to add on to what Susie said. Somebody might have done something slightly different, or somebody might have done what Susie did plus something extra maybe to check their solution. One thing at the end here is that wait time, and that is huge. And I know I don't need to tell teachers that because they realize how important wait time is, but anytime we're asking these questions, allow 3 to 5 seconds or even more for the students to process and think. This poster right here is also available on the CNI Google site. It's also available at Print Shop if you wanted to have it printed through your school. So one of the big questions I get from teachers is how does this meaningful math task resource fit in with the recommended framework for planning math, or the math menu is what we call it. Actually, they both fit hand in hand, and so I'm going to go through that really fast. Prior to giving students a meaningful math task, the first thing that we would do with students in the very beginning of the lesson is a quick appetizer. That just means a quick review, getting their mouth salivating and their brains ready for some math. So just some sort of review. Then that first course is going to be students grappling with a problem and engaging in a math talk. So that's where we would give the students that meaningful math task. The second course in our menu for effective instruction is to provide some direct instruction and some guided practice. And that's exactly those teaching points right there. So course 2 would be those teaching points. And then that dessert, and the reason we call it dessert is hopefully there's a sweet payoff where you can see what the students can do on their own. This is their independent practice. This is where students now can take what you've done in guided practice and direct instruction and try it on their own. This might be that students try to resolve that meaningful math task using that new strategy they just learned. This also would be a good time to collect some formative assessments or pull a small group if you need. There is a math unit planner available on the CNI Google site that follows this framework for teaching, and this is just an image of it. So over the past 2 years, I've heard a lot of these same questions over and over and over again. So I wanted to take a few minutes to address those questions. This first question is, I have a lot of students that are finishing the tasks immediately, while others seem like they're productive, but they're taking a lot longer. So what can I do to keep everybody on task and differentiate as needed? Well, in order to address this question, because we're getting this everywhere, a new page has been added to the front matter of the teacher's guide. And that page is called Meeting the Needs of All Learners. And here's what that looks like. It just gives us a few tips on how to differentiate. So for example, getting students that are having a hard time getting started to create an I notice and I wonder chart. So start listing the things you notice about the problem. Start listing the things that you wonder about the problem. Another suggestion is to flip the task. So instead of having students find the solution to this given task, change the task a little bit, like take out the numbers, but give the students a sample solution. So, for example, you might say, what if I change the problem slightly? My answer is 18. What could be the rest of the problem? What could be the other numbers in the rest of this problem? Or if it was like an area problem, for example, if my area is 18, then how would this change the problem? What would my measurements be then? So flipping that task a little bit. Or challenging students by having them create a different task or modifying this task. I've done this a lot, and students really seem to like this one. You might say something like, I don't think this task was challenging enough for you. How would you modify it and create it more challenging? Or how might another student solve your new task? The other thing you want to do is those kids that answer faster than expected, be prepared to give them a couple follow-up questions. So what if I changed this number in the problem? Would I still get the same solution? Or what if I did this first instead of what you did first? Will it still take me down the right path? The last thing that I want to recommend that's on this chart right here is use that stop sign strategy. Again, this stop sign strategy is a chart or a problem-solving strategy that's available on the CNI Google site. And this is really important because a lot of students, like we said before, they just want to do something with the numbers. They don't stop at each point along the way and think about the problem. Getting kids, especially those strategic learners, to use that stop sign strategy will really help them slow down and think about every part of that problem. So another question I get a lot is, how long should it take to do a meaningful math task? Let me start by saying meaningful math tasks are meant to be a lot different than our old problem of the day. The problem of the day was something that teachers did at the beginning of the lesson, before the lesson actually got started. And then when the lesson did start, it usually wasn't at all related to that problem of the day. The meaningful math tasks are meant to directly connect to what's being taught in the math lesson, as they are part of the math lesson. As far as time goes, it could be that students are really productively grappling for maybe 20 or 30 minutes. And then they might even have a really good math talk for about 15 minutes. That means that your direct instruction, guided practice, and independent practice might not all occur within that same day. You might not be able to finish that whole lesson in one day. Therefore, sometimes meaningful math tasks, including that direct teaching, might take up to 2 days. Sometimes teachers tell me that they spend an entire week on a math task, and I know other teachers have heard this too. But that's not actually spending a whole week solving that one task. That just means that teachers, as they are teaching new skills or new strategies throughout the week, they might be referring back to that meaningful math task that they did on Monday. And they might say, I could have used the tool we learned today on Thursday to solve that meaningful math task that we did at the beginning of the week. They're just making connections to it so the students have a context for why they are learning these new tools. Another way to use the meaningful math tasks across the week is to make sure that you put the meaningful math task on your focus wall along with your essential questions. So you'll notice here that I've displayed a meaningful math task. It's to the right of that calculator poster. And I've also included a few sample responses from student journals. This serves as an exemplar of how students could be or should be answering that task. This shows the depth that they should be explaining their solutions. So as I use the meaningful math task on Monday or Tuesday at the beginning of the week when I introduce it, at the end of that lesson, will probably ask the students the essential question again and have them share out some of the tools or strategies that we learned that we could use to answer this question. And then throughout the week, as I'm teaching new strategies, we keep going back to this chart that has our essential question on it, and we're identifying other ways that we could be answering this essential question. But I'm connecting it back to that meaningful math task too, saying, oh yeah, I could have used circle models to answer that meaningful math task. Maybe we'll try that tomorrow. So just making sure that you're just making that connection. It's not that you're spending a whole week on a single task. Another question that I get a lot is, how do the meaningful math tasks fit in with math journals? Well, when I use math journals, I do a 2-page spread. I usually have student work on one side of the math journal, or one page of the math journal, and that's anything that the student's grappling with. It might be a meaningful math task or just some sort of open-ended problem. That's how we're starting off our lesson. Then on the other side is anything the teacher gives the student, any new learning the student's getting, and that's the teacher input. That might be a new strategy, a new model, some sort of chart that they might need to better understand mathematics. And all of that teacher input is directly related to that meaningful math task I just gave them. So let me say that again. On the right side of the page is student work related to that meaningful math task. On the left side of the page then is any new strategy I'm teaching related to that meaningful math task. And then I usually save just a little bit at the bottom to apply new learning. This might be, now that I learned this new tool, I'm going to resolve the meaningful math task using that new tool. Or now that I learned this new tool, let me reflect on it and think about one question I still have about it, or one new thing that I learned today. Let me give you a couple examples of the teacher input section here. That's where teachers usually have the most questions. I'm just going to flip through these really fast. These are just some different types of tools and strategies that teachers could put into student journals after doing that meaningful math task. If students are in kindergarten just learning, you say one number for each thing that you count, or how you can count by tens and then some additional ones. I'm just going to flip through these really fast. All of these different tools actually came out of the Math Expressions book. Pictures of these tools are also available on eduplace.com, eduplace.com. All of those tools are on eduplace.com are directly linked to Math Expressions. I also want to show you one example of what this looks like in an actual classroom. So this was a student's journal in kindergarten. I started by giving the students a problem. They grappled with it, they answered it, and then I pulled all of the students to the carpet so that I could teach them a new way for solving problems like this. So the new way of solving problems was to introduce a math mountain. As they were on the carpet working on math mountain work mats, I had the assistant in that classroom glue a picture of the math mountains into the students' journals. And then at the end of the lesson, the students went back to their journals, and I said, now that we've learned this new tool, let's use this new work mat that we found today to solve our problem, and then draw a picture of what we did on the work mat in our journal. So everything in that interactive notebook or that journal interacted with that meaningful math task. The last thing I wanted to do was show you how to access the meaningful math tasks. Like I said before, we've doubled the number of meaningful math tasks. There's about 18 to 20 tasks for each 9 weeks. That means teachers can do about 2 each week. You're going to start by getting into your email. You are going to click on this little keypad looking thing in the upper right hand corner. When you click on that, you're going to see the image that you see right here. It gives you a couple choices. You want to get to the CNI Google site, so you're going to click on Sites. When you click on Sites, you're going to get a page that looks like this. You probably won't see the words curriculum and instruction on the page here, so what you will need to do is you will need to physically type in curriculum and instruction in the search bar. Once you type in curriculum and instruction, you're going to be taken to the CNI Google site, and then you would just go to the math page and scroll right down for meaningful math tasks. I hope you enjoyed today's module. That was just a very fast crash course of how to use the meaningful math tasks. If you have any questions, feel free to email me. It's Dawn with an E, D-A-W-N-E, Coker at ccs.k12.nc.us. My email address is also at the very beginning of this video. At this time, I'm going to just ask that you stop the video and just take a minute to reflect on all of the information that we shared today. Try to think of one new learning. 2 things that you'll try differently in your class this year, and then 3 ways that students can benefit from using the meaningful math tasks. Have a good day. Thank you.